Okay, we're getting ready today for the upcoming quiz number 10. Going to go over some of the concepts today to hopefully make you feel a little bit better as usual. This will also be available online, so if you want to watch this video later, if you want to have a clean copy of this and try it on your own, the key itself will also be online as well. So here we go. Factor each completely. First rule of all factoring at all times. Golden rule. What do they have, in common? If anything. Well, if they do, that needs to come out first. And whatever I have left then is what I'm going to attempt to factor. And in a lot of cases, just by taking out that common factor, it makes this a lot easier. Now, some of you in the past, when we've been doing problems like this, said, well, wait a minute, what if I don't take the greatest common factor out right away and I can still factor it though? So some of you may say, what if I had like 3n squared plus 3n and then had n minus 6? It factors out the same way, it multiplies or FOILs out the same way. I understand that, but it's the same thing as doing, let's say, putting your answer as 2/4 when it's really 1/2. Punch them in the calculator, get the same thing. In reality, are the same thing? Not quite. So take out your greatest common factor. Here, again, if I have the same variable, take out the one with the smallest exponent. And sometimes you may even get fortunate enough that you don't have to do much of anything, except take that greatest common factor out. Now, it may not always work out that way. For instance, here, they all don't have an n. 5 goes into 10, but it doesn't go into 49. So again, I've got to do one of two things here. I've either got to do some mental work. So in this case, I'd be like, okay, what multiplies to 10 is going to get me to 5 and 2, 10 and 1. Ooh, 10 and 1. 10 and 1 can get me to 49. Because I've got 50 and 1. I want the positive to go with the bigger value, and I'm good. Now, what if I'm looking at it for a while and I don't get it? What am I supposed to do then? Well, it's not an option we've talked about a lot in here, but it is an option that you have. It takes a little longer, but sometimes those of you that don't like playing around with numbers, you can do this. And again, it's called slide and divide. I've only shown it a couple of times to you. Whatever your coefficient is of your squared term would slide down to the end, and then I'd do a diamond of what I had there. So here I'd need to find two numbers that multiply to negative 50 but add to 49. So I'd be like, okay, let's see. Well, it's a positive and a negative. Positive number is going to be bigger. Let's see. Oh, 50 and 1. Right. But I'm not done because you're like, they don't look the same yet. That 5 that I slid down would divide in here. 50 over 5 is 10. 1 doesn't go into 5, so that 5 slides back to the front, and I get the same thing. Again, only go to this if you're really having some issues with one of these, because otherwise the mental math will serve you so much better later. So just something to consider. Here, I got an m squared I can take out of each one. Once I do that, again, don't lose your m squared. That's still part of your solution. But like we did before, we're going to do a little mental math here. So let's see. Can I do more with this? 9. I got 9 and 1. Oh, I think 9 and 1 might do me well. 9 and 1. I want the positive to be bigger, and I need a negative product. Yes. Well played. But the little things like understanding multiply to negative 9 means I get a positive and a negative. Knowing that my middle term where I add is going to be positive, making sure the bigger number is positive. Those are the little things you can do to keep yourself from losing points. Treat this, if you get confused, just like you would x squared plus 4x plus 3. Do a diamond just the same way. You're like, well, it's 3 and 1. That'd be 4. Okay. But instead now of just being x times x is x squared, x squared times x squared is x to the fourth. But be careful. I know somebody's thinking it right now. Do not try to break this down. There's no such thing as a sum of squares. If it was a -1, yes, I could. But it's not, so I'm not. Now that we have that straight, same thing here. Treat it like it's x squared minus 16. You're like, well, it's like x plus 4x minus 4, except it's squared. Ah, but this time, what I just got done lecturing you about, I do have a difference of squares. I can't break down the sum. There is no such thing. But the difference, I can. What do I square to get each of my terms? Well, x and 2. It's minus, 1 is plus, 1 is minus. Again, you have to get all the way to the end. It's not a, well, what if I do? No, there's no what ifs. You will. Cubes. What do you cube to get each of the terms? Once you know, you've got to play the pattern. 4 plus 3m. I just used the sign that's in the middle. And then remember your pattern. Square your first term, change the sign, multiply your two terms together, and square the whole last term, the 3 and the m. Nice thing, won't break down no more. Happy, happy, happy. Same thing working here. And if there happen to be numbers there and you see a cube and they're not perfect cubes, look for that greatest common factor to take out. Same idea. 3x and 1, keep the sign in the middle. Square the whole first term. Change the sign. Take the product. Notice I'm not using that negative. I'm always looking at these when I'm talking about my products. Plus 1, and I'm done. Expansion. Now again, you could multiply all of this out over and over and over, but you know, who wants to do that? You're like, oh, here comes this back. When I'm expanding, if I do it with this, remember my first term. When you're going through here, your first term takes the largest exponent and goes down 1 each time. So in other words, I've got 4y cubed plus 3 times 4y squared times my second term plus 3 times 4y, my second term squared, and we'll talk back about the pattern here in a minute, plus my second term cubed. 3, 2, 1, 0 as far as degree on my first term, and as far as my second term, 0, 1, 2, 3. Now again, you could just multiply that all out 3 times and it would get you the same thing, but who wants to do that? Not this person. Make sure you multiply this out. So 3 times 16 is 48 times -1 is a -48y squared. -1 quantity squared is 1 times 3 times 4 is 12y. -1 cubed is -1. Same thing if I multiplied it all out, but again, who wants to do all that? Finally, the fourth. All right, here we go. First term to the fourth plus 4, first term cubed, second term, and notice each time my degree is adding up to the same thing. Over here it was degree of 3. 2 and 1 is 3. 1 and 2 is 3. Degree of 3. Plus 6x. Oops, that should have been out here. 4. 3 and 1 is 4. 2 and 2 is 4. 4x y cubed, we are not going to run out of room, plus 4y to the fourth. 4, 3, 2, 1, 0, 1, 0, 1, 2, 3, 4. It's going to be kind of large. 4 times 4 would be 16x cubed y. Here, distribute that out. 16 times 6 is 96, x squared, y squared. Here, 64 times 4 is 256, xy cubed. And finally, 4 to the fourth is 256, y to the fourth. Degree of 4 on every single term there. And again, whether you want to multiply it and then multiply it and then multiply it again is up to you, but I don't want to do that. Okay, evaluate each of the following functions at the given value. Again, you can use the store function if you want here. You can just crank it out in your brain, which is what I'm going to do. Negative 4 cubed is negative 64. Negative 4 squared is 16 times 7. It's 112. 8 times negative 4 is negative 32 minus 4. Let's see here. I believe we're going to get out positive 12 will be our f of negative 4. And no, do not divide by negative 4. Now it's a label. Don't do it. Be cautious. Plugging in the 3. Again, store function's fine, calculator's fine, I don't care. 3 cubed, 27. 3 squared, 9. 16 times 3 is 48. Don't forget your signs. Don't be careless. So let's see. 36, 42, negative 6. It's f of negative 3. Again, just a label. Just a label. Okay. Perform the indicated operation. Add them. Okay. Now, am I going to take it if you write it like this? Yes, but seriously? In order, greatest degree to least. We know better than this. We're going to do it better than this. G times F. Foil it out. N cubed plus n squared plus 2n plus 2. Okay. Watch what it's asking you to do. G of n minus h of n. Okay. G of n minus, notice the parentheses because I'm subtracting the whole quantity, not just the n to the third. Basically, that's just going to change the signs on all of the second part of my problem. Greatest to least degree. There we go. Composition of functions, do what's inside first. Go to G, plug negative 2 in wherever there's an x. So negative 6 plus 3 is negative 3. That's G of negative 2. And now take that negative 3, and plug it in for f. And that would be f of g of negative 2. And the cool thing is, if you're watching this at home, you can pause me. If it's during class, you're probably not going to get quite so lucky. Okay, find the inverse of each function. Again, switch x and y, solve for y. This is already y, so x equals negative 4 minus 1/3 y. Solve for y. Add the 4 over. Multiply both sides by the reciprocal, which is negative 3. because that'll take care of this for me. And no, you don't have to have the -1 there for it to be right. And I suppose you could even load it as -3 times the quantity x plus 4. I just like to multiply things out. So we're good there. Momentarily the bell's going to ring. Ignore it. It's not for you. Add the 16 over. Divide by 4. And again, when you're doing these, I don't care if you leave it as x plus 16 over 4, or if you decide you are going to write it out more like you were going to graph it. I'm happy with either. I really am. So that's good to go too. So 19 and 20, we're going to get a little help from the calculator. State the maximum number of turns the graph of each function could make. Sketch the graph. State the number of zeros. Approximate the zeros to the nearest tenth. Approximate the minima and maxima to the nearest tenth. Okay, we got lots of things going on here. So first things first. So we're going to graph. So it looks like I'm going to have 1, 2 turns, okay? Because basically that just means how many mins and maxes am I going to have. So I have 2 turns. So then it says go ahead and sketch the graph. Well, I want to be somewhat accurate here. So I'm going to look to see how many values. So -1, 0, 0, -5, 1, -2, 2, 3, 3, 4, or -5. Get my sketches in. State the number of real zeros. There will be 3 zeros. Notice it didn't ask me to, oh, it does ask me to approximate them. I was about ready to be bad. Now remember, always look to see if you can swipe a couple. And I notice right here, I can get one here. One of my zeros is at -1, but the other ones it looks like I'm going to need to find in another manner. Now I can find them in that other manner by using the calculate function on my calculator, second trace, and looking for the zeros over here that way, where I trap them below and above my x-axis, up to the nearest tenth, so 1.4, second trace, looking for the zeros. Again, this time, since I'm coming from the top, I'd start at the top, take my other guess from down below. And remember, anything to the e just is treated as though it's 0. So 3.6. And then I have a min and a max, so I will go ahead and find each of those. Looking for the minimums, so that's down here. Anywhere to the left of my minimum is fine. Anywhere to the right is a-okay. So I notice there's an e. So my min is at 0, -5. My max, anywhere here to the left of that maximum point right there. Anywhere to the right for my other part. So 2.7, 4.5. Which would actually be about here, which is more important on why sometimes you'd like to find your max and your min before you actually graph it. Just so you can do that. But since I didn't put it in that order, I won't count it against us. So we'll do that one more time. Scooch this over a bit. So one last one here. fourth, x to the third, squared plus 4. Okay, I approximately see what the graph is going to look like. Okay, it looks like I'm going to have 2 real zeros here. And it looks like I am in luck that one of them is going to be found at 1. So I got myself a little bit of help getting started here with my graph. So let's see. I know the one here. I'm going to go ahead and find my other one. Again, since I'm coming up, my first point will be below, my second point above. So I've got one at 1 and one at 2.4. And it also looks like I have a maximum, which is right here. So anywhere to the left, then to the right. And that just makes that 0, so 0, 4 would be my max. And it looks like I have 1, 2 mins. So we'll go ahead and we'll find those. Anywhere to the left of it, anywhere to the right. So my mins are at negative 1.1 and 2. One more here. Down in here, so to the left, to the right. 1.8, negative 4.3. And I finally am ready. Let's go ahead and get that drawn in with all of my information. And then finally, we have down here at the bottom, use synthetic division on 21 and long division on 22. So synthetic division, remember to change your sign before you get to the box there. I have no holes this time. Bring my first term down, multiply and add, multiply and add, multiply and add. And remember, whatever degree you started with, so in this case I started with a degree of 3, start one below that, and when I get to my remainder, I just put that over my divisor. If I'd had a 0, I'd have had no remainder. Now, when I get to this last point, now we're fortunate we weren't asked to do this one using synthetic. We'd have had to divide everything through by 8. But fortunately, we were not asked to do that, so we don't have to. So again, no holes. Get our little area ready here for some side work to do. So remember, it's first term divided by first term. Whatever you get goes up here on top. And whatever you get from that first answer, you're going to multiply it times your divisor. And whatever you get is what you're going to put below and do your old school division with. 73 minus 9, 64k squared, and I'm going to bring the rest of my terms down and start the process over again. First term divided by first term. Notice it's the 8k I'll be dividing by each time. And then I multiply that by the 8k plus 9. And that is what I will subtract by, and yes, I have to do it one more time. And why is this? Because 8k still can go into 64k. They're of the same degree. So one last time, 64k divided by 8k is 8. Eight times the 8k plus 9 is 64k plus 72. Subtract that, I'm left with 1, which is my remainder of 1 over 8k plus 9. And like I said, this key is online. The video will still be online. Blanks of this will be online, so you'll have an opportunity to be able to get all of this stuff set. And we'll have some time for questions in class too. Good luck.